Hello everyone, good afternoon. Welcome to our OSS India session. In this session, we will share our experience of working with the Android open source project. My name is Amit Pundir, and I'll be co-presenting this session with my colleague Sumit Semwal. We both work for Linaro. Unfortunately, Sumit got injured recently, so he won't be able to come and share the stage with me. But before we begin, here's a quick disclaimer on the trademarks and the copyrights. Right, so the agenda of this session is that we are going to talk about what is brewing in aosp lately, the major features that have landed or dropped in the aosp in the recent times. We will also talk about the community projects like DevBoards for Android and aosp devs, which aim to focus on the tooling, reference boards, and the collaboration workspace for aosp system developers. A quick recap on Linaro, DevBoards, and the aosp. Linaro needs no introduction in the open source ecosystem. We are an upstream-first organization with a focus on the development of open source software, including the Android open source project for the ARM architecture. Linaro has been a long-time advocate of aosp development boards. For years, we have been talking about the importance of aosp and dev boards at the developer forums like LPC, ELC, Linaro Connects, etc. Linaro supports aosp on a number of member development boards. This helps us use these devices as a vehicle for aosp feature development and validation. And to ensure that the Android operating system runs smoothly and efficiently on these devices, Linaro performs extensive testing coverage on each supported device. This testing includes both functional as well as performance testing. We test run CTS and VTS test suites to ensure that our dev boards meet the requirements of the Android compatibility document. Again, I can't stress enough on the testing part. We have been doing extensive testing coverage. Linaro has been doing an excellent job on the testing part. And these numbers alone are just Android and aosp specific and do not include non-Android testing done on these development boards. In total, we test 13 Android kernel variants as of now across 7 user space combinations. You can take a closer look and you can take a closer and more detailed look at the Android testing combinations at the above mentioned URL. Now coming to the main topic of the agenda, that is keeping up with the Android open source project. The aosp is constantly evolving with new features and bug fixes being added regularly. In this session, we will talk about the major features that have been developed or dropped from aosp in the recent times. So some background on Android bootloaders before I start with the first feature project. Android fragmentation is sadly not just limited to the system or the kernel level. Android has a bootloader fragmentation problem too. Those of us who are tracking aosp over the years would agree that Android bootloader or the boot image header versions are a pain to keep up with. On almost every release, Android updates the bootloader requirements. And unlike Linux kernel, there is no agreement or consensus on a common bootloader among Android vendors. So each vendor ends up implementing Android bootloader features in their respective bootloader and keep forking it for every new release or new platforms. And in the worst case, maintain different versions of the bootloader for the same SoC running different Android release versions. Meanwhile, these vendor bootloader implementations add little to no value in the differentiation of Android functionality, because no one buys an Android phone because of the bootloader. Luckily, Android developers recognized this fragmentation problem too, and they have been working on a generic library called Generic Bootloader Library, also known as GBL. So regarding this name, I have a theory that we have seen GSI, right, generic system image. Then we have seen GKI, generic kernel image, which are aimed towards solving the fragmentation problem from the system and the kernel point of view. So I'm hoping that the GBL is going to play a very important role in fixing the Android fragmentation at the bootloader level. So what is GBL? It is an EFI app developed in-house and distributed by Google over ci.android.com. It provides standardized Android bootloader interface, and it provides vendor-agnostic interface, which abstracts the underlying platform-specific bootloader implementation. Thereby, the vendor doesn't have to work on its bootloader implementation every time a new Android bootloader feature or bootloader requirement drops. Please note that GBL also defines custom EFI protocols which need to be implemented in the vendor bootloader. So it is not just a drop-in replacement, it needs certain EFI protocols implemented as well. Hopefully those EFI protocols will be pushed upstream as well. GBL also make use of the trusted components across the trusted firmware and verified boot ecosystem. Here is what the GBL boot flow looks like. You can see that the boot started from the stock bootloader. You will see that the ABL has kicked in. ABL will, so in this case, because it's a development board and we do not have access to the Android bootloader source code as such, so we are chain loading U-boot from ABL. And then U-boot is loading the GBL, and GBL is taking care of the Android boot process. On a typical product, the ABL should be able to just load the GBL and run with that. For more technical details on how we have enabled the GBL or tested GBL on our development boards and learn from our mistakes, please check out this presentation that we did a couple of months ago at the Linaro Connect. Another major development in aosp that has been happening for last couple of years, I think, is to make aosp builds page size agnostic, mostly from the 16 KB page size point of view. So what is a page size agnostic aosp build? It means that the aosp build do not make any page size assumptions, and the same application can run on a 4K or a 16K aosp build. 16 KB page size aosp builds reports 5 to 10% increase in overall performance at the 9% additional memory cost. You can check out the technical or non-technical details at the aosp blog URL that I have posted. Now, to make the OS a truly page size agnostic, aosp has been refactored from the ground up, and they make sure that they got rid of the page size macro, which makes the hard assumptions about the page size of the OS, by making sure that the binaries are 16K aligned, and by building binaries with separate loadable segments. There are some noticeable changes in how Android manages different file systems in a page size agnostic build as well. For the most performant combination, the files, they recommend that the file system block size must match the kernel page size. But for compatibility, some file systems support different page size enablement from a page size agnostic build point of view. For example, on F2FS, which gives you the most performant build, the block size is equal to the kernel page size. Meanwhile, for ext4 and EroFS, which support page size agnostic builds, they are built with 4K block size. Now, due to this current status of file systems, it is advisable to stick to ext4 or EroFS for page size agnostic builds at this point. This could, however, change as the development continues. Again, for more technical details on how we have enabled page size agnostic builds on our devices and the challenges and workarounds that we have used, please check out our presentation that we did a couple of months ago. Now, other than these two features that has recently landed, there are some of the smaller but notable additions in the aosp recently. There were a few system core project changes which caught our attention, and these changes simplify booting aosp from external storage devices, for example, an external USB disk. A new kernel command line argument got added to find the boot device, the aosp boot device, based on the partition UUID. One of the catch that we ran into is that the UUID parsing is case sensitive. So UUID should be in the lowercase letters, otherwise it won't work. So this was a status like a couple of months ago. I'm not sure if they have already fixed it or not, but I just wanted to point that out. Android also introduced a more aggressive user space hook to enable asynchronous probing of kernel modules. Honestly, I have not checked if devices other than Pixel are using this feature on their devices or not. Next up is the aosp-main compatibility patches. Android makes use of the downstream Android makes use of the Android shared memory driver. Now, Android is in the near future, so I cannot comment whether it's going to be near future or a far away future, but they have plans to replace Android's aosp-main driver with the upstream memfd driver. And memfd currently doesn't support aosp-main iuptl commands. So certain applications treat any buffer given to them as an aosp-main buffer, and they try to invoke the aosp-main iuptls, which fail, and then the application aborts. Now, in order to preserve the compatibility between those legacy applications and memfd, this aosp-main compatibility shin layer is introduced, which will handle aosp-main iuptls from the memfd. Now, so keeping up with the aosp updates and integrating them with local or device-specific customizations can be challenging at times. Here, I have listed down some of the common breakages that we encounter while working on aosp. The core or incompatible framework changes. Most recent feature breakages on our devices are due to HAL transitions from HIDL to AIDL. So we had to fix our device manifest files accordingly and pick or modify the default implementations from the cuttlefish device config. Keeping up with the ever-challenging build configuration tools within aosp is also something we need to look out for. A recent change in Sung disables adding additional android.mk makefiles in the external project, and that broke a few of our projects. As of now, android.mk makefiles are only allowed in the device configuration directory. aosp also started moving aggressively towards the basal build configuration, but it seemed to be limited only to GKI and GBL build repos so far. Last but not the least are the GKI ABI breakages. Though almost all of these are vendor kernel specific issues and nothing to do with GKI as such, but I thought it's a good idea to share the most common GKI boot failures that we have run into. Especially during the GKI development cycle, while the kernel ABI is still open and not freezed for that particular Android release. Top in the list is the symbol list modifications. The out-of-tree drivers are allowed to use only a certain subset of exported kernel symbols. These are maintained as a separate symbol list, and this list keeps on changing during the development cycle for that particular kernel release, and it may break vendor drivers. Vendors shipping protected kernel modules run into boot failures too. The protected kernel modules are the upstream kernel driver modules, which are signed by GKI, and vendors are not allowed to ship their own version of that particular driver as a replacement. GKI kernel config changes can lead to an unexpected breakages as well. Next up is keeping up with the external projects. One of the most important aspects of supporting a device in a big project like aosp is to keep up with the always churning changes. be it the aosp like we saw in the previous slides, or keeping track of any external projects. Maintaining dev boards in aosp or aosp on development boards is just like maintaining any other Linux distribution. So when working with upstream projects like aosp, we need to ensure that our modifications and enhancements align with the upstream code base. For this session, I have only listed Linux kernel and Mesa Freedreno projects, but the list can go on depending on the features being supported and maintained on the specific device. Working with the upstream Linux kernel and aosp brings many long-term benefits, but it can be a pain at times. I've listed down a few. For example, upstream do not count device tree nodes or sysfs nodes as stable interfaces, and they keep getting renamed in a couple of releases, and that breaks aosp at times. The onboard peripherals, which gets probed through device files, are sorry. The onboard peripherals which gets probed through device files are often a pain with SE Linux's access control policies. Convincing upstream developers that the bug you reported is a valid bug can get a bit trickier too. This is one of the frequent contention points between upstream developers, upstream kernel developers, and aosp platform developers. If you are lucky, you get to reproduce the bug on Debian or a standard Linux distribution. Otherwise, we just keep arguing with the developer, with the maintainer. It gets more and more difficult when a bug is tied to a firmware binary, because over the years, like in the case of bootloader binaries, vendors do not care much about the firmware, do not care much about the legacy devices, or rebuilding or fixing firmware bugs linked to those specific, a very small number of user base. At times, we run into cases wherein some non-fatal regressions go unanswered too. Lately, there is a huge spike in the LTS breakages due to half-baked auto-cell cherry picks. Tracking issues due to incomplete auto-cell or auto-select cherry picks can be a session on its own. The other big project or the set of projects that we use or integrate on our dev boards is Open Graphics, that is Freedreno. Integrating Freedreno in our aosp builds bring many benefits, and there is no doubt about that. But like any other upstream project of any nature, Freedreno and Mesa have their own limitations and pain points. Starting with fairly regular build breakages with aosp, we have seen that Google's GFX stream projects, cross-platform changes in different projects can break Mesa builds too. And although Freedreno aims to provide comprehensive support for the Adreno GPUs, there may be cases where certain advanced features or optimizations are not fully implemented. For example, you cannot enable full Vulkan support on aosp builds if we are using Freedreno on I won't call it legacy device, but on a device like RB3 and RB5. Right, so other than these technical challenges, there could be non-technical hurdles as well. If you are tracking aosp or Android releases, then you must have noticed this major shift in how aosp development is done upstream. So this is the screenshot that I shared earlier in my slide deck. And you may or may not have noticed the small notification on that screenshot. That link points us to a more detailed notice stating that starting March 27-25, aosp-main has gone into read-only mode. So there is not going to be active development happening on that public branch. And a new branch called Android latest release is introduced, which will always point to the latest Android release branch. So what is Android latest release branch and how to make use of it to submit your changes? As I mentioned earlier, Android latest release branch manifest will always point to the latest Android release drop. Google will accept changes only on the Android latest release branch because aosp-main is read-only. These changes will be cherry-picked into the internal branch after reviews, and they will appear in the next quarterly release drop. And there is no notification mechanism for external developers to know whether their change got accepted or not until the next release drops. The next policy change, which we have all noticed, is the curious case of missing pixel device configurations. This has led to a lot of unrest and confusion in the custom ROM and aosp communities, and understandably so. Device configurations in this context refers to the build configuration files and binary blobs that you use or that you need to compile and flash a working build on that particular pixel device. Up to Android 16, device Google contained configurations for the pixel devices that are currently in their support window. But that part is missing now. Googlers have explicitly claimed and reassured that despite the missing pixel device support, the open source or the QPR nature of the aosp releases still remain the same. And the developers still have the option to build cuttlefish and GSI targets from the sources for their experimentation. In reality, though, the pixel devices have long been served as a reference platforms for undocumented aosp hooks, so missing pixel device configurations are considered to be a big setback for custom ROM developers. Cuttlefish is great and all, but it is still a virtual device with a lot of VM-specific glue and a lot of cuttlefishness and less of real hardware. So as you can see, I deliberately put the aosp's major policy changes at the end so that I can align those changes with the next topic of my presentation, which is around the community development boards and collaborative aosp development. Building and contributing to aosp can be daunting, especially when dealing with a device bring up fragmented documentation and scattered resources. Fortunately, new community-driven initiatives like DevBoards for Android project is changing that. From providing reliable reference boards and pre-built images to fostering collaboration around the out-of-tree patches, the documentation, DevBoards for Android project is reducing the friction of aosp development and hardware experimentation. And most importantly, it is trying to bridge the gap left by Google's recent shift in aosp development. The project goals for DevBoards for Android is that we hope to enable this project as an umbrella space for collaboration of aosp system developers, enabling a community of system developers who are trying to keep aosp up and running on their devices. We aim to work together on common issues and develop generic aosp features or common HALs that can be used across multiple platforms, across multiple SoCs. This project supports aosp-style source code navigation and Gerrit reviews. This should help new developers get familiar with the Android style of patches. We have added few reference build targets and HALs. We have also used this project as a staging area for the aosp patches submitted for review, and which have not yet landed on the Android latest release branch. For example, we recently pushed GBL support for our devices using DevBoards and we used DevBoards for Android, Gerrit for all the code reviews. This workspace serves as a staging area to host upstream aosp-focused devices as well. This project will hopefully provide a wider range of devices for developers to choose from or do prototype work for their proof of concept or work. Another community level project I want to highlight is the aosp devs project. Like DevBoards for Android, aosp dev project also shares the common goal of enabling a community workspace for the aosp system developers, where developers share aosp bring-up experience and troubleshooting ideas. And that brings us to the end of the session. keeping up with the AOSP is hard, and we believe that these upstream and developer-focused initiatives will be instrumental in sharing and co-developing generic software solutions. While these projects don't fully replace what pixel device configurations, and the gap left by aosp-main branch, but they are an essential part of the post-aosp-main ecosystem, offering a more open, reproducible, and community-driven AOSP path forward. Thank you. So one more thing before I wrap up here. We are hosting an AOSP Dev Room in India FOSS 25 next month. It's going to be in the Bangalore. So we have AOSP Dev Room full of wide range of Android topics. So please do join us if you are interested in talking or learning more about AOSP. Thank you. I think I'm right on time. So if you guys have any questions, I can take a couple, maybe. Yeah, thank you very much.